another example. We're going to solve this right triangle. Okay, so solving a triangle means I'm going to identify every angle and every side. So in this case, we're just being asked to solve for this particular side, but let's talk through how we can identify all of these parts. So let's start with the angles. Okay, so we see we have the 62-degree angle and the 90-degree angle. So if I want to find this angle up here, why don't we just go ahead and call that A for now? Then I know that 62 and A together must equal 90 degrees, right? So 62 degrees plus A is equal to 90 degrees. So A is equal to 90 minus 62 degrees. So let's go ahead and do that subtraction. So 90 minus 62, so 28 degrees. So that's this angle right here. All right, so now let's look at these side lengths. So I can find x because I know the angle 62, right? So x is the opposite of 62, and 19 is the hypotenuse. So using the sine ratio, so sine of 62 degrees is equal to x over the hypotenuse, which is 19. So to solve for x, I would multiply both sides by 19. So x is equal to 19 times sine of 62 degrees. So let's talk about how to plug that into your calculator. I'm going to use the ALEKS calculator so you can see how to do that. Notice we have to be in degree mode. So if you're switching in between degrees and radians, we would use that button. So I want to make sure it's in degrees because that's what I'm using. So sine of 62 degrees is this, and then I'm going to multiply that by 19. And then we're told to round to the nearest tenth. So rounding to the nearest tenth, I'll look 2 places past the decimal point. Since the 100th place is a 7, I'll round that 7 to an 8. So x is equal to 16.8. And so that would be the x. If we were now going to find this side, we would have a couple of options, right? We know the angle here, so we could set up another trig ratio to find that side. Like I said, I know this particular question didn't ask us to, but I think it's good practice. So if we use this angle, the 28, opposite of that angle would be this one. I'm just going to call it y. And then we know I'm going to choose this nice whole number and not an approximation. So let's use opposite and hypotenuse. So we'll use the sine ratio again. So I can say sine, this time of 28 degrees, is equal to y over 19. And so again, we would multiply both sides by 19. And y is equal to 19 times sine of 28 degrees. So we'll jump over here to the calculator. Let's clear this. So another way to enter it would be using the parentheses. So we could say sine of 28. And the parenthesis again here and hit equal. Okay, so again, rounding to the nearest tenth, we would go to 8.9 for y. Okay, let's take a look at one more example. Let me make this a little bit bigger. Okay, so, it says use the appropriate Pythagorean identity to find the indicated value for the acute angle theta, and then write your answer as a simplified fraction if possible, and also rationalize denominators. All right, so there's more than one way we can look at this. It is often really helpful to draw a right triangle. So let's do that. Let's start with what we know. So what's given is that cosine of theta is 9/41. So that actually gives us a right triangle and enough information to identify every angle and side. So we need to figure out, we just need to call one of these two angles theta, and it doesn't matter which one. And if cosine theta equals 9/41, remember 9 is the adjacent side. So adjacent to theta would be this side, so that's 9. 41 would be the hypotenuse, so that's opposite the right angle, that's this side. So I have enough information to find the third side using Pythagorean theorem. So again, we can call this side whatever we want. And so I can say, okay, x squared plus 9 squared is equal to 41 squared. So x squared is equal to 81, or let's say plus, x squared plus 81 is equal to 41 squared is 1681. And so x squared is equal to, subtracting, that would give us 1600. Take the square root of both sides, and x is equal to 40. So that tells me this side. All right, so now that I have all three sides, I can find any trig ratio of theta. So sine of theta, again, would be opposite over hypotenuse. So that would be 40/41. All right, and the last thing we're going to talk about are some special right triangles. So two special right triangles that we're going to use over and over again throughout the course is our 30-degree, 60-degree right triangle and our 45-degree, 45-degree, 90 right triangle. And so these, you want to know the ratio of these sides. So we're going to look at the sides are 1, the hypotenuse is 2, and the other leg is the square root of 3. And again, we can use Pythagorean theorem to verify that. And with the 45, 45, 90, of course, we're looking at an isosceles triangle, right? Both sides would be the same because both angles are the same. And so we have 1, 1 for the legs. And if we use Pythagorean theorem, we would see that that third side is radical 2. So this is always the ratios that exist when you're looking at a 30, 60, 90 or a 45, 45, 90 right triangle. And this is something that you really do want to memorize. Remember also that you could be looking at this in terms of radians. So I think it's always a good idea too to remember, even though we could take the time to convert this, but it's nice if it's just something that comes quickly to you, but that pi over 3 is the same as 60 degrees. Pi over 6 is the same as 30 degrees. And pi over 4 is the same as 45 degrees. And so that's really going to be used interchangeably. But then a lot of these questions will just be asking you to find the exact value. That's what we're going to spend a lot of time doing over the next few lessons. But for these triangles, if I said, okay, find the exact value of cosine of 45 degrees, we would want to think of this triangle, and then we would think adjacent over hypotenuse. So that's 1 over the square root of 2. Again, rationalized, we would multiply the top and bottom by square root of 2. And so this is the square root of 2 over 2. You could be asked to find tangent of pi over 6. And so again, the triangle isn't typically given. These are two triangles that you want to memorize and know off the top of your head. So remember, this is the same as 30 degrees. So I'm looking at this triangle. Tangent is opposite over adjacent. So opposite would be 1. Adjacent is the square root of 3. And then rationalized, again, multiplying by the square root in the denominator, we get the square root of 3 over 3. And so this is something that's just, like I said, going to come up over and over again, and something that we'll become really, really familiar with.